Kia ora Year 12. This video is going to go through how to find what we call standard normal probabilities using a table. And if you've been doing the Education Perfect work, which most of you have, it goes along with the second task I've set you on the normal distribution. So these are the examples that we're going to do in this video. There are quite a few of them. So there are 8 that I'm going to go through, and you'll see that they all involve Z, right? So Z is a letter that we reserve for a special kind of normal distribution, okay? So the Z variable, when we're doing probability problems, is always used when we have a mean of 0 and a standard deviation of 1. And so we write that like this, Z with that little squiggly thing that we call a tilde. So that means Z is distributed normally, big N, with a mean of 0 and a standard deviation of 1. So remember that we write the mean as mu equals 0, and sigma is equal to 1. So this is a really artificial setup, okay? It's not like in life we have lots of things that have an average of 0 and a standard deviation of 1, but it lets us solve real-world problems. So for example, if you know that dog weights are normally distributed and the average dog weight is 12 kilograms and the standard deviation is 2, the way that we're going to solve problems like that in about one lesson is by turning it into this Z variable first. And when we do it on our graphics calculator, that's how the graphics calculator, I think, does it as well. So we're going to learn that later, but for today what we're working with is just how to work with the normal probabilities that are Z ones, so standard normal probabilities. Okay, so if you've already done the EP task, you might want to just have a go at doing those questions yourselves, but I'm going to go through them really slowly and show you how to use the table that you'll get given in the exam. So let's start with looking at this first one, which is the probability that Z is between 0 and 0.32. So the first thing to do is to make sure you've written it down like that with P bracket, meaning the probability of, and then we always are going to sketch it because I have to fix my typo on every single page. The probability in the table is set up in a particular way. So here we're going to draw the line in here. We're going to have 0 here for the mean, and we're going to put in 0.32 somewhere above it, and we're going to shade that in. So that's the probability that we're wanting to find. And as you know from the earlier work, when we find normal probabilities, we're looking for the area under that curve. And now we look at the table, and we have to check that what we're finding matches the format given to us in the table, right? So here's the table, right? And the table is all of these numbers in here are probability numbers. But we have to first make sure that the table fits our pattern. So we've got it where it's colored in from 0 to 0.32. And that's exactly how we want it to be able to use the table. Okay, so you can see here that the table is giving us a value here at 0 and then another value here above 0. So all we have to do now to find the probability that Z is between 0 and 0.32 is we look in the table for the 0.32, and we do it like this. We start here and we look at that first decimal place, which is 0.3. So we come down to here, and now we're going to be working somewhere in this row. Now the second decimal place is the 2. So we work our way along here until we get to this number here, right, which is the 0.32. So that means that my answer to that question is 0.1255. So it really is that easy once you get going, right? You set your problem up in this format, and then you use your table. So let's do another one. The probability that 0 is between, where's it gone? That Z is between 0 and 1.46. So our probability is already written in the right form, and it is for all of these ones here. Okay, and now we're going to sketch that probability. So there's my 0, here's 1.46, doesn't really matter where you put it, and we're colouring in that area. And we look at the table and we know that it's in the right format. So all I have to do now is to go down to my table, and I'm finding 1.46. So I go down here, I go all the way down to 1.4, and then I go across to here, which takes me to 1.46. So my answer is 0.4279. So that's all you have to do. Okay. Now for this next one, we've got Z is less than 1.35. So when we sketch it this time, we're going to see that something's a bit different. Here's 0 and here's 1.35, but we want all the probability from here back. So this time what we're going to do is use some common sense about the shape of that distribution. Here's my probability distribution for the normal, and we know that the area under the whole curve is 1. So that means that the area on this side here must be 0.5. So what I'm looking for this time is a number out of the table, and then I'm going to have to add that 0.5 on. So here's 1.35 here. So that's the bit that I want from the table. Now we go to the table, which is very conveniently just down here. So we want 1.35. I go down here, I find my 1.3, I go across to 5, and I find that my number here is 0.4115. So my probability here is going to equal 0.5 plus 0.4115, which equals 0.9115. Okay, let's have a look at this one, which is the probability that Z is above 0.32. So again, what we're dealing with this time is not quite the right pattern. So here's 0, here's 0.32, and we want the probability that Z is above 0.32. So we want this area in here. But we know that this whole side has an area of 0.5. And we know that the table is going to give me this bit in here. So we go to our table and we need to subtract that bit. So the answer is going to be 0.5 minus, here's 0.3 and here's 0.2. We already did that one. So 0.5, take away that area. So 0.5 minus 0.1255, which gives me 0.3745. Now the next one is a little bit funny, and honestly I'm teaching you this because I know some of you are going to ask me about this weird stuff in the table. In real life you're actually going to do these using a graphics calculator, so this doesn't matter as much as it did back when I was learning normal tables, but there you go. So if we've got a very precise number that we're trying to find out the probability for, we're going to do, so to find the probability that Z is between 0 and 2.13, we're just going to use the table, right? We're going to go down here to 2.1, and then we go across to 2.13. Where this differences column comes in is these are little add-ons that we do for when we've got very pernickety values that we're trying to work with. So to deal with this little 8 here, we come over to this bit of the table. So let's first of all just draw the picture of what we're trying to find, check that it's in the nice easy format, and we can see that it is. So it's going to be this. Here's my 2.13 number, so it's going to be 0.4834, and then I have to add on a tiny little bit of extra stuff. So I choose the 8 column, and I'm going to add on 3 to the very last decimal place. So it's going to be 0.4837. So it's a little add factor. Okay, I'm only doing one of those because I think that you'll get some practice at those with Education Perfect, but in real life they're not that useful. The next one is one where we've again got to do something to fix the graph up. So the probability that Z is between negative 1.6 and 0 is going to look like this. Here's negative 1.6 and here's 0. So you can see that it's not on the right side for my probability table, but you can also see by symmetry that this area here is the same as this area here, where I've got from 0 to 1.6. So the probability that that Z is between negative 1.6 and 0 is equal to the probability that z is between positive 1.6 and 0. And that's an easy one with my table. I just come down here to 1.6 and the answer is 0.4452. So we're using the symmetry of the distribution. Now in the next one, we've got the probability that z is less than 1.6. So that means it's back down here. Sorry, less than negative 1.6. But we know that that's the same as the probability of being above 1.6. So the probability that z is less than negative 1.6 is the same as the probability that z is above 1.6. And this is one where we use the tables to get this area here. So that's equal to 0.5 minus 0.4452, which is equal to 0.0548. Just one more to do. I know this is probably the most boring video I've ever made. This one here is where we've got to link up two probabilities. And again, if you draw the graph, it's much easier. So here's my bad graph. There's 0. I want z between negative 0.8 and positive 0.98. So thinking about how I'm going to use the table, I'm going to split it up into two areas. The first one is going to be that one, and then I'm going to add on this one. Okay, so the probability that negative 0.8 is less than z is less than 0.98. It's going to have two numbers added together. So where's my 0.8 number in here? We go down here, here's 0.8, so it's 0.2881. And where's 0.98? It's here, over at this number here. So I need to add that number and that number together. So 0.2881 plus 0.3365. That gives me this, 0.6246. So there you go. Hopefully that sets you up pretty well. If you were having trouble with the Education Perfect, you should be good to now go and practice in the Walker workbook. I'm going to do some more videos this weekend on how to find the next level up of normal probabilities. So those go like this one here. Let's just find an example that I've got in here. Okay, so this is what we're going to next, is where we've actually got a real life thing. So for example, if we've got apples, they're normally distributed and they're not going to have a mean of 0, right? They're going to have a mean of 30 and they're going to have a standard deviation of 5, for example. We're going to have to take that and we turn that into a normal distribution like the ones we've just done the video on. So we go from X and we turn that into a Z distribution. Okay, so but that's coming up later on today. Thanks for watching. Hope everyone's going okay in lockdown.